Hi, in this video we're going to talk about end behavior of polynomials, and this is part of section 3 of chapter 2, polynomial. And as the name indicates, end behavior, it just means the behavior of the graph at its ends. We talked about polynomials last week and we said the low degree polynomials are linear, quadratic, and cubic, and I drew the parent functions in this case. So that's not the only direction those functions could be in. I could see a line that has a negative slope and it will have a different end behavior, which means the graph at the ends will be different. I could see an upside down parabola. I could see another direction of a cubic. Now today we're going to be talking about not only x cubed, x squared, and x, but also I want you to get familiar with x to the fourth, which we name it quartic. It's a W shape, and you can see both directions. And again, as we said, our objectives today is to look at the graph at both ends. So each graph will have two ends. This is what we're going to look at. To summarize, there's a little trick to know how the graph is oriented. We're going to be looking at two keywords. We're going to be looking at leading term or leading coefficient also. So the leading term has a leading coefficient, and we're going to be looking at the degree. And I made here a little table. So we're going to look at the degree and we're going to look at the leading coefficient. If the degree of the function is even, like 2, 4, 6, and so on, polynomial function, and the leading coefficient is positive, I'll take an example. Y equals x squared. Even degree, leading coefficient is positive. Then the graph will look like this, and we call it up end behavior. That's in easy words. And here an example would be x squared, or even 2x squared or 3x squared. The fancy language would be limit as the function goes to infinity right here. And this is a template. You cannot change it. We always going to look at two ends, positive infinity and negative infinity. When the graph goes to, when x goes to positive infinity, the graph goes up. And when x goes to negative infinity, the graph is also up. This is where up comes from. And if you want to understand x, here's the x-axis. Here's positive infinity. Here's negative infinity. So when we say limit as x goes to positive infinity, this is the right end. And as x goes to negative infinity, this is the left end. If we have a leading coefficient that is negative, like negative 5x squared, how would the parabola look like? It will be an upside down parabola, as you know, so it's going to be a down, down. And in this case, at both ends, the graph is going to be down. With the odd, it's a little bit different, and I'll take the easy example of x cubed, and the leading coefficient positive, so like a 2, and the graph will look like this. It doesn't point in the same direction. To the right, it's going up, and to the left, it's going down. And what happens if we have a negative leading coefficient, like negative 5x cubed? The graph will be upside down, so the right end will be going down, and the left end will be going up. And up means infinity, down means negative infinity. So for odd positive, the graph is down, up, and for odd negative, the graph is up, down. We're going to apply that to the following examples, 1, 2, and 3. So I want you to take some time and to answer the end behavior of the given functions. You can answer it first in easy words like up, down, and so on. But after that, I want you also to write and use the limit notation. And again, this is a template that won't change. You're just filling this in with whatever you think happens at both ends of the graph.